And 6 girls. Find the probability that the choices contain 4 boys, an equal number of boys and girls, more more boys than girls. There should have been more boys than girls. We can have more boys than girls. So part A, it says 4 pupils are to be chosen from a class of 8 boys and 6 girls. Find the probability that the choice contains 4 boys. So you want the probability that you get 4 boys. I'm going to write 4B for 4 boys. So to get 4 boys, that means you are choosing how many boys? 4 boys from how much of them? 4 pupils are chosen. You're choosing 4 boys from 8 boys times. That means you wouldn't be choosing any girls out of the 6 of them. And that means you're dividing by the total number of students is 8 plus 6, which is 14. And then you're choosing 4 in total. That would be the probability of choosing 4 boys. Of course, we go for our magic calculator and we work that out, which is 8, choose 4, and we multiply that by 6, choose 0, 6, choose 0, then we divide that by 14, choose 4, 14, choose 4. That works out to be 10 over 143. 10 over 143. That's it. Nice and easy, soft. Right. Now the next thing that we want to work out now, it says part B. It says an equal number of boys and girls, an equal number of boys and girls. So to get an equal number of boys and girls, that means you're choosing 2 boys and you're choosing 2 girls. So to find the probability of choosing 2 boys and 2 girls is, that means from the 8 boys, we are choosing 2 multiplied by, from the 6 girls, we are choosing 2 divided by, we're choosing 4 from the 14 students. So that's what we're doing. So let us evaluate this probability now. So we're going to work this out. Let's go ahead and work this out. So this is, of course, going to become, let's look at our calculator. All right. So we're just going to fix this a little bit. Up top here, this was 6 choose 2 times 8 choose 2. That's 60 over 143. This is 60 over 143. Now the last part says, if you choose more boys than girls. If you choose more boys than girls, then that means, let's write it right here. So we want the probability of your choosing more boys than girls. If you're choosing more boys than girls, then what that means is you want more boy and girl. Simple. You want to choose more boy than girl. That means you can either choose 3 boy or 1 girl. That's more boy than girl. Plus, there's a chance you can choose 4 boy and no girl. So those would be when you're getting more boys than girls. So the probability of you choosing 3 boy and 1 girl is where you're choosing 3 boy from 8 times, if you're choosing 1 girl, you're choosing 1 girl from 6, and that's being divided by, remember we are choosing 4 from 14, plus over here, you're choosing, remember you're choosing 4 boys from 8, multiplied by you're choosing no girl, so you're choosing 0 girl from 6. That's being divided by 14, choose 4. Nice and easy. So you go ahead and you work this out in your calculator. 8 choose 3 times 6 choose 1 divided by 14 choose 4. This part works out to be 48 over 143. 48 over 143 plus this part over here now works out to be 8 choose 4 times 6 choose 0 divided by 14 choose 4. And that works out to be 10 over 143. 10 over 143. So now 48 plus 10 is 58 over 143. 58 over 143. And that's it. Easy, soft. That's the probability for the last one of getting more boys than girls. To get more boys than girls is 58 over 143. 58 over 143. That's it. Easy. Question says the letters of the word conclude are to be arranged. What is the probability that the arrangement has all the consonants together and begins with the consonant A and ends with a vowel and ends with a vowel and has all vowels together? Let's look at the first part. The letters of the word conclude is to be arranged. Find the probability it has all consonants together. Now, first thing we have to do is look if no letter is being repeated. Yes, this is already being repeated, and so we know that this is permutation with restriction. So we're going to do it on the whiteboard. Or let's not go whiteboard yet. Let's stick here. Let's look at part A. As you can see, how many letters are here? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 letters, so n equal 8. All right, n equal 8. But since it have been restriction, restrictions, it's not going to be 8 factorial. We know it's going to be divided by how many letters repeated? C, C, 2, 1, O, 1, N, 1, 1, L, 1, U, 1, D, 1, E. So we know it's being divided by 2 factorial. But it wants now all the consonants to be together. So if all the consonants are together, let's look at that. All the consonants together. So if you draw up your 8 boxes, 1, 2, 3, 4, 5, 1, 2, 3. Then that means that, let's say this is a 5 consonants. All right. So 5 consonants, 5 is here, 4 can go here, 3, 2, 1. Then you have your 3 vowels. You have your O, U, E, right? Your 3 vowel, which would be a 3, 2, then 1. But guess what? Think of these 5 consonants as one thing and these 3 as one thing. So it's like you have 1 plus 3. 1 plus 3 equals 4. So in the numerator, it's going to be 4 factorial times, most important part is times what? 1, 2, 3, which is 3 factorial ways of arranging this. That's going to be your answer. That's part A. 4 factorial times 3 factorial over 2 factorial. So that's 4 factorial. And if you want to see it in the calculator, for me to work it out, it's just going to be put in the fraction 4 factorial times 3 factorial times 3 factorial. That's being divided by 2 factorial. That's what you get. You work this out. Tell me what you get. 72. That's your answer, 72. Nice and easy, soft. Nice. Part B. Part B says, what is the probability that it begins with a consonant and ends with a vowel? So it begins with a consonant and ends with a vowel. So pretty much what you want is you draw up your 8 boxes again. I don't like how I'm drawing the box. So what I'm gonna do is I'm gonna just get the real thing, the real box. Here's a real box. All right. This is a real box. This look like the real deal. Yeah. Yeah, man. You drop 8 boxes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Cut it up in 8 boxes. I want to begin with a consonant. If you begin with a consonant, that means any one of the 5 can go here. Either a C, a O, a N, either a C, a N, a C, a L, a D can go here. So any one of those 5 letters, all right? Any one of those 5 letters can go here. And then now it wants to end with a vowel. There are 3 vowels, so any one of the 3 can go here. Then that's 2 letters out of the way. And so 6 letters are left back, so you can go 6, 5, 4, 3, 2, and 1. So that means part B, to begin with a consonant and end with a vowel, is going to be 5 times 6 factorial times 3, and that's all being divided by 2 factorial. So we work this out, and part B will give us, let's check it on the calculator right here. So it's going to be 5 times 6 factorial times 3. This is all being divided by 2 factorial. We work that out. That is 5,400 ways. 5,400 ways. Then part C says find the probability. Oh, my golly, my sweet Lord. Notice I haven't been finding probabilities so far. So far, everything that I've done is showed you number of ways. So of course, we always need to divide it by 8 permute 8. So check out what is 8 permute 8, by the way. You always have to check that out. 4 factorial divided by 2 factorial. All right, remember always divide it by total possibility. I haven't been dividing by total possibility. My gosh. Total possibility, by the way, remember is n factorial, 8 factorial over 2 factorial. All right, so 8 factorial over 2 factorial. So this is divided by 20,160. We always need to divide it by 20,160. We have to divide it by total possibility. I haven't been doing that, so my apologies right here. Finally, now it has all the vowels together. If all of the vowels them they're together for part C, then let's say the vowel them they're the front part, right? So you can put any one of the 3 vowel here, so any one of the next 2 right there, so then the next vowel get this spot. Then you have the consonants there. All right, your 5. Your 5. This is 5. This is 5. Then any one of the rest of the consonant here. 4, 3, 2, and 1. All right, so what's the probability of all the vowels being together? The probability of all the vowels being together is going to be equal to, first thing we need to find out what's the numerator, simplifying to be. These three vowels together are like 1. And then this is like what now? These three vowels together are like 1. All right, these three vowels are like 1, and this is 5, so that's 6 factorial in the numerator times this right here is 3 factorial over 2 factorial, and then all of that is being what now? All of that is then going to be divided by 20,160. That's how we take on this question. Easy, soft. So we put that in our calculator and we get the answer. Easy, soft. Yeah, man. Of the number 4223177 are rearranged. Find the probability that the arrangement starts with 7 and ends with 7. So if the arrangement starts with 7 and end with 7, first things first, this is permutation, and it is permutation with what? It is permutation with restriction and repetition, because we see 2s are repeated and 7s are repeated. So if you want to start with 7 and end with 7, then how much other number left back? 1, 2, 3, 4, 5 numbers. So anyone out of the 5 can go here, 5. Any other number can go here, 4, 3, then 2, then 1. And so that means the probability that it start with a 7 and end with a 7, probability it start with 7, so it start with a 7, S hyphen 7 means start with 7, comma, end with 7, probability start with a 7, end with a 7, that is going to be equal to, start with a 7, end with a 7, so it wants start with a 7 equal, end with a 7, that's equal to, all of this right here, as we can say right now, if it start with a 7, there's only 2 ways we can choose a 7 right here. That's why I put the 7 there. And then when another 7 is here, there's only one way. There's only one way right here. So the probability of starting with a 7 and ending with a 7 is, as you can see, it is 2 times 5 factorial, 5 factorial over how many numbers are being repeated. 2 is repeated twice, 7 is repeated twice, so it's over 2 factorial times 2 factorial, and then it is of course divided by n factorial. N is how much? 7 factorial over 2 factorial times 2 factorial. That is going to give you all the possibilities. So all of this will work out to be equal to, let's put it in the calculator. Put it in our calculator. So we're gonna have 2 times 5 factorial, and that is divided by 2 factorial times 2 factorial. Close up that bracket, and it's all being divided by, so we work out this now, it's all being divided by 7 factorial over 2 factorial, 2 factorial times 2 factorial. We close up that. That's 1 over 21. That's the probability of getting it to start with 7 and ending with 7. 1 over 21. So there's a slim chance it will start with 7 and end with 7. Find the probability the arrangement is a odd number. So to find the probability it is an odd number, always remember an odd number ends with an odd number. So the probability of it being odd is equal to the probability of getting an odd number is that this is going to be equal to chance of you getting an odd number. If it's an odd number, then this last number can either end with a 3, a 1, a 7, or a 7. So that's 4 numbers it can end with. If it is an odd number, write it down again. If it is an odd number, it can either end with 3, 1, 7, or 7. That's 4 options it can end with. It can end with 4 options. So if it can end with 4 options, right, it can end with any one of those 4. Then we can have any other number. It can be then 6, 5, 4, 3, 2, 1. So to get an odd number, it's going to be 6 factorial times any one of those 4 numbers, because it can be any one of these 4, divided by 2 factorial times 2 factorial. And then this is going to be divided by 7 factorial over 2 factorial times 2 factorial. 7 factorial over 2 factorial times 2 factorial. So this is what we work out, and this will be the probability that it is odd. Easy, soft. Let's go ahead and put this in the calculator. Put this in the calculator now. All we're going to do is change. Let's just change this now to 6 factorial. So let's go back now. Dun, dun, dun. All the way over here. This one was 6 factorial. And this one was 4. We'll go ahead. 4 over 7. So there is 4 over 7 chance it will be odd. Very easy, soft. Then it says find the number, the probability for which arrangement starts with a 7 and ends with a 7, given that the arrangement is an odd number. So we need to do that. I like this question now. This question says find the probability that it starts with a 7 and ends with a 7, starts with a 7, ends with a 7, given that we know that it is odd. Given that it is odd. Given that it is odd. All right. This is conditional probability. So conditional probability is going to be the probability of us getting a 7 at the start and a 7 at the end, and it needs to be odd. It needs to be odd at the same time. So it needs to start with 7. It needs to end with 7. It needs to be odd, divided by the probability of it being odd. So let us work this out now. Easy, soft. So I love to use my table. So what we have here is it often odd. Let's try to get it in one now. So we need it to be start with 7. So there are 2 ways it can start with 7 because there were 2 7s. It have to end with 7. All right, it have to end with 7. One way it can do that, and then it have to add. But once it end with 7, it already add. So how many numbers leave back? 5 numbers leave back. And so this is 5, 4, 3, 2, and 1. Then now, this is just going to be now, it will just give us a number of ways for it to be start with 7, end with 7, and odd. That's what we get. So we just need the number of ways now for it to be odd. So this probability is working out to be, this is 2 times 5 factorial, 2 times 5 factorial over, look at the number of ways for it to be odd. Number of ways for it to be odd, remember, We said for odd number, it can end with either 7, 7, 3, or 1. So that's 4. And then since it odd, it can start with any other number. There's 6 other number, 5, then 4, then 3, then 2, then 1. So that's just going to be divided by 6 factorial times 4. So divide it by 6 factorial times 4. That would be what we get. So we work this out now. That will be 2 times 5 factorial divided by 4 times 6 factorial, and you get 1 over 12. So the probability of this happening is 1 over 12. Nice and easy, soft. This works out to be 1 over 12. This last one is equal to 1 over 12. Easy question. Soft. Capital T.